Today we're going to talk about graphing quadratic functions, and first thing you need to know is that when you graph a quadratic function, the shape it makes is called a parabola. And so today's lesson is called graphing parabolas. And so in front of you on the screen I have 4 different parabolas that are graphed. And you'll notice that there's a lot of variety, and the first thing I want you to recognize is that the solutions, which are the x-intercepts, that depending on which way the parabola opens and where the vertex is, there could be 0, 1, or 2 x-intercepts, right? So in the first one we can see that the green parabola crosses the x-axis 2 places. Same thing with the blue. The yellow one hits it and bounces off, so there's only one solution, and the red one turns out to have no solutions at all. And so just as a reminder, x-intercepts and solutions mean the same thing when we're talking about quadratics. All right, let's talk about some other important parts of the graph of a parabola. We have this thing called a vertex, and the vertex is actually that point on the parabola where the parabola changes direction. So if you look at the green parabola and you start on the left side and you are moving in the direction to the right, you'll notice that as you start out, the parabola is decreasing. The y values are getting smaller. It gets to this point where it changes direction and then starts to increase. That point is called the vertex of a parabola. So in this video we're going to talk about how we find out how many solutions there are, how to find the vertex. While I'm at it, another thing is just a reminder, we're always concerned about the y-intercept when we graph a parabola, and that is nothing more than setting x equal to 0 for the quadratic. So let's start out by looking at some different quadratics and find how many solutions there are without graphing them. Okay, so in order to find the number of solutions, number of x-intercepts, we use something called the discriminant test. So discriminant test, all right? And here's the discriminant test. You just take the number under the square root in the quadratic formula. So you're going to find b squared minus 4ac, and one of 3 things is going to happen. The number you're going to get is going to be greater than 0, equal to 0, or less than 0. Those are the only possibilities. When the number you get is greater than 0, there will be 2 solutions, or 2 x-intercepts. If it's equal to 0, there will be 1 solution, and less than 0, there will be no solutions. And hopefully that makes perfect sense, because we're talking about a number under a square root, and anytime we have a negative under a square root, we say there are no solutions. Okay, so let's just do real quickly, let's do some practice with the discriminant test, and then we'll get back to graphing. So I'm going to put on the board 3 quadratics, and we're going to, without graphing them, without solving them, we're going to find out how many solutions there will be, or how many x-intercepts. All right, so in the first case, in all these cases, a is 1. And then b in the first one is negative 4, c is 3, so when we do b squared minus 4ac, we get 16 minus 4 times 3 times 1, which is greater than 0, so therefore there are 2 solutions. All right? For the next one, b is also negative 4, but c has changed to 4 this time, and so when we do b squared minus 4 times negative 4 times 1, I did that backwards, we get exactly equal to 0, so we could look at this and say there is 1 solution. The last one, a is 1, b is negative 4, they all have the same b. I could have left that out. And then c turns out to be 6, so this time when we take b squared minus 4 times a times 6, the value, 16 minus 24, is less than 0, so therefore there are no solutions. Okay, so that's the discriminant test. That's a good idea to do that when you're starting out to factor a problem and you're not sure if it's factorable or not. You definitely want to be able to use the discriminant test. All right, so let's go ahead and talk about graphs of parabola, and what we're going to do is start with a really simple one, and that's the parabola where the b and c are 0. So I'm going to go ahead and talk about the graph of y equals ax squared. All right, so we remember from a previous chapter that we had something called a basic function, y equals x squared. We didn't we might have called it a parabola. I don't know. We're not sure. We have a way of graphing this, the shortcut where we go over 1 up 1 over 1 up 3, and this is the basic graph. We remember when we multiply the graph, the function by a number out in front, that this is a vertical scale change, and depending on the value of a, it can make it taller, shorter, or it can flip it over the line. So let's go ahead and look at, for instance, y equals 2x squared. That means the y's are 2 times as big, and if we were to graph that, we would have something that looked like that. Okay, that makes sense? And then if instead of y equals 2x squared, we had y equals 1/2 x squared, it would have the effect of flattening it out, and so that would be y equals 1/2 x squared. Okay? And then the last thing we could do is we could simply put a negative in front of the x squared, and that would have the effect of flipping it over the x-axis. Likewise, and I'm not going to graph all of these, but I am going to talk about them. If I had y equals x squared plus 4, I think everybody would know that that would mean to move the basic graph up 4. Y equals negative x squared plus 2, there are 2 transformations. First we'd go up 2, and then we would flip it over the x-axis. And then the last one I want to talk about is what happens if that minus 3 is in the parentheses, and I hope everybody remembers that transformation is left 3. Okay? So far so good. Let's talk about how we graph quadratics that are in the form such as this. If I give you y equals 2x squared minus, no, that's not what it is, sorry, x squared, and then I've got minus 2x minus 3. All right, and so our job is to graph it, and when we graph it, we want to find the x-intercepts, the y-intercept, solutions, or, sorry, those are x-intercepts. What do I want? I'm talking about the vertex. And then we're also going to talk about something called the axis of symmetry. All right, perfect. All right, so the best way, we're going to go ahead and start with the x-intercepts. And so the fastest way to find those is, if it's factorable, go ahead and factor it. Always the fastest. Quadratic formula, completing the square, take too long. All right, and so we know that at 3 and at -1, this graph is going to have x-intercepts. So I'm going to go ahead and start that. And at 3 here and at -1, the graph is going to cross the x-axis. Likewise, we haven't talked about the direction of opening, and that's an important concept. And the thing that tells us the direction of opening is always the a value. So a is the number in front of x squared, and when a is greater than 0, the parabola will open up, and when a is less than 0, the parabola will open down. And I think we did talk about that, maybe not directly, when we were back here and we talked about that a. You remember that. Okay, perfect. So here we go. We know it's going to open up, so maybe the next thing we would like to do is find the y-intercept. And the y-intercept is super easy, because all you need to do is make the x's 0, and that the y then would be -3. So -1, 2, 3. It's going to cross the y-axis there. Okay, and then the last thing we want to do is find the vertex, and there's a couple of ways to find the vertex. If you have the x-intercepts, the vertex is always going to have an x value that is the midpoint of the x-intercepts, right? So we have an x-intercept at 3 and one at -1, and if we add those two together and divide by 2, we get 1, and so that means at 1, our vertex will have an x value of 1. Now we have to find the y value, right? Because a vertex is a point. And so we're going to go ahead with x squared minus 2x minus 3 and plug in 1. And what happens is the y turns out to be -4. All right, so I'm going to go back to my picture that's up here, and I'm going to go to 1, -4, and now I have a pretty nice graph.